You have heard it 10,000 times in your life, and you have never noticed the tempo. The click of a car turn signal, a small mechanical pulse, somewhere between a metronome and a heartbeat, coming from the dashboard every time you flip the lever down. The light flashes, the sound clicks. The car waiting next to you at the intersection is doing the same thing at almost exactly the same rate. The driver behind you, in a different make and model from a different country, is clicking at the same rate too. The tempo is universal. And the reason it's universal is not a coincidence. It's a 1959 American engineering standard calibrated to the threshold of human peripheral vision. Here on the reason why. Sit in the driver's seat of any modern car and flick the turn signal lever. The amber light starts blinking. You hear the click coming from somewhere behind the dashboard. The light flashes about 90 times per minute. It doesn't matter if you're driving a Toyota in Osaka, a Volkswagen in Munich, a Ford in Dallas, or a Tata in Mumbai. Every modern passenger vehicle on the planet flashes its turn signal at the same approximate rate. The convergence is not religious. It is not regulatory uniformity by accident. It's a 1959 American engineering specification that quietly became the global standard. And the reason for the specification is your eyes, not your car. The story starts in 1959. American highway traffic was exploding. The interstate system was 3 years old. Cars were getting faster, headlights were getting brighter, and the early electric turn signal systems built into 1950s sedans were a mess. Some flashed at 30 cycles per minute, slow enough to look like a steady amber light. Some flashed at 200 per minute, fast enough that drivers behind couldn't tell if the car was signaling or had a fault. The Society of Automotive Engineers was asked to fix it. They formed a working group called J59DO. The committee's task was simple: find the flash rate at which a typical driver would reliably perceive the signal as a signal. Here is the part the committee figured out by testing real drivers on real tracks. The human eye does not detect intermittent light the way it detects steady light. Below about 30 cycles per minute, the eye sees a steady glow with brief dimming, not a flashing signal. Above about 140 cycles per minute, the flashing fuses back into a steady glow because the visual cortex can't keep up. Between those extremes, there is a window where the eye reliably parses the light as alternating on and off. The center of that window, where the signal is most legible to a driver glancing in a side mirror, is around 90 flashes per minute. And here is where the engineering became permanent. The J590 committee specified the legal range as 60 to 120 flashes per minute, with 90 as the design target. They picked it because the test data showed drivers reacting fastest at exactly that rate, with the highest signal detection accuracy in dawn, dusk, fog, and rain. Slower or faster, drivers missed turns or misinterpreted signals. At 90, drivers reacted within 400 milliseconds. The 1959 spec was published. American manufacturers adopted it within a year. European and Japanese manufacturers, who had no equivalent standard, copied the spec because their cars now sold into the American market. Within a decade, J590 was the global default. But here is the second part of the spec nobody talks about: the clicking sound. The original 1950s electromechanical relays that drove the lights also made a physical click as they switched. Engineers could have silenced the click with rubber dampening. They didn't. The committee specifically required the click stay audible because drivers would forget the signal was on after taking a turn. The audible click is a reminder, calibrated to register at the same flash tempo. Modern cars use solid-state circuits with no mechanical click, but every manufacturer added a synthetic click through the speakers, played at the same 90 per minute rate, because driver studies showed people drove 15 miles with the signal on. There is a corollary in the J59A spec that you have probably encountered without knowing the name. It's called hyperflash. When a turn signal bulb burns out, the surviving bulb on the same circuit gets twice the current and starts flashing at roughly 180 cycles per minute, faster than the J590 ceiling. The committee designed this on purpose. A hyperflashing signal is outside the perceptual window. It reads as an obvious malfunction to the driver, prompting them to replace the bulb. The fault state is itself a signal. Every modern LED-equipped car simulates the hyperflash electronically when a bulb dies, even though the underlying current load doesn't change anymore. The eye still expects 90. Anything else means something is wrong. So the next time you flick a turn signal lever and the click starts, remember, the tempo is not arbitrary. It is a 1959 American engineering measurement of the human peripheral vision threshold. It got written into a single legal flash range that spread to every car company on every continent within a decade. The amber light is flashing at a rate calibrated to a driver glancing in the side mirror at dusk. The synthetic click in your speaker is calibrated to the same tempo because engineers measured driver behavior and discovered humans simply forget. Every modern car contains a tiny piece of 1959 visual physiology, ticking 90 flashes a minute every time you change lanes. Look at the next car turn signal you see. The tempo is one of the most universal pieces of human factors engineering on Earth, and you have stopped hearing it because it works. The 1959 SAE J59 Assay Gabblage Going Committee picked the 6120 flash per minute range, not because it was convenient, but because it sat at the only window the human eye reliably parses as alternating on and off. Below 30, the eye sees steady glow. Above 140, the eye sees fused glow. Between those two thresholds, around 90, drivers react fastest, miss fewer turns, and correctly interpret signals across dawn, dusk, fog, and rain. The committee didn't pick a tempo. They measured the eye, and the eye picked it for them. American manufacturers built the spec into a 1960 model year. Within 10 years, every car company on every continent had matched it because their cars sold into the American market. The synthetic click in your speaker exists because driver studies showed humans drove 15 miles with their Tays and all, and if there was no audible reminder. Even the hyperflash fault when a bulb burns out is calibrated to fall outside the perceptual window, so the driver registers it as a malfunction. Every dimension of the click was measured against your physiology. The blinker is not a stylistic choice. It is a mirror of the human eye, ticking 90 times a minute on every continent, calibrated to a driver glancing at dusk through a side mirror in fog. If this kind of small engineering decision, quietly shaping your daily life story, is your speed, there is a whole channel of stories like it. The reasons behind everyday objects you have stopped questioning. Subscribe so the next one finds you and quietly lands in your feed without you having to look for it once.